Here, innovation is a way of life. We think big, start small, fail fast, and learn even faster. Technology unlocks a world of meaningful insight. From a sea of data, we can recognize patterns, solve complex problems, and enable the government to formulate effective policies.
We work in an agile, bold, and collaborative environment here, so things can move very quickly. But we share a common purpose, that is, building tech for public good.
Diversity in our teams is key to opening our minds to different possibilities and driving innovation. On our journey, there are many uncertainties and unknown dangers to navigate.
To stay on course, we stay connected with our users and stakeholders to ensure smooth deployment and adoption of our technologies.
In cybersecurity, we test systems, processes, and people for vulnerabilities. Starting with limited information, we collect small pieces to solve the puzzle. This requires a deep understanding of tech and an even deeper understanding of people.
During my internship, I had the chance to work with a person with visual impairment. I realized then that even though digitalization benefits many, we have to ensure that no one gets left behind.
It's meaningful and a privilege to help nurture the next generation of leaders in tech. I've also gained much from mentoring and engaging the younger generation of tech talents. GovTech has changed over the years. We'll continue to evolve and empower Singapore in this age of rapid transformation.
Cyber defense isn't about removing the functionalities and benefits of tech. It's about arming ourselves with the knowledge and awareness to safeguard what's important to us.
We go beyond our work desk to get in touch with the people. We learn through connecting with them. This is how we improve. People are at the heart of what we do.
GovTech is a family that builds bonds beyond work. I've come across many who have dedicated themselves to mentoring and helping me grow as a person.
It's rewarding to see my family and friends benefiting from something I have worked on. I'm humbled to have the opportunity to do my part and improve their lives.
Smart Nation isn't a vision with a finish line. It's a mission to always strive to be better. How can we push the boundaries a little further and make lives a little better?
Our motivation comes from improving the lives of the people. Yours, mine, our friends, and family, and the generations that come after. We believe that there's an exciting journey ahead, and this is only the beginning.
Good evening, everyone. Great to see everyone here again today. Thank you for joining us tonight. We're excited to have DataScience SG as our co-organizer for this meetup. I'll leave Ivan to share more about their community later. Okay. I'm Karen, and together with our colleagues, we run the StackX community here in GovTech. So before we start, we'd like to run through a couple of house rules that are up on the screen now. First, please note that the webinar is being recorded, and we ask that your questions be kept to the topics presented here today to keep the session meaningful. And finally, please feel free to ask and upvote your questions throughout the webinar via the Q&A function that can be found at the bottom of the screen. Please avoid posting questions in the main chat, as our speakers won't be taking questions from there. So the program today that we have is up on screen. It's an exciting one. So our Senior Director for the Data Science and AI Division will give the opening, and Watson will share about how we analyze feedback on municipal issues with natural language processing and deep learning. This will be followed by Jing, who will be presenting on how to prototype a natural language processing workflow and an overview of GovTech's forward deployed data science teams. So please stay with us for a short networking session with speakers and the team after the Q&A. And before I hand over to Ivan to share more, allow me to share in the next few slides more about GovTech as well as our community efforts. So GovTech is now currently about 3,000 strong. Our work can be broadly classified into the three areas shown here: product, services, and cyber security and governance. So we have about 700 over developers under the product teams that develops products for whole of government and strategic national projects. We also have capability centers, one of which is the data science and AI division that we'll be sharing today. We also have sensors and IoT, digital services, cybersecurity, and infrastructure. The product team also manages the whole of government infrastructure, from our move to commercial cloud, to data centers, to issuance of devices to all public offices. In the second pillar is the services group that accounts for more than half of GovTech's staff. They play an important role in managing technology in over 60% of government agencies here in Singapore. And the last pillar is also important. It is our cybersecurity as well as governance. So cybersecurity in the government is led by our government chief information security officer that sits in GovTech. And to ensure all the work that we do is safe and secure, we have a governance team that sets the ICT policies and guidelines across government. Next slide, please. So to engage and connect with the tech community like yourselves, we have formed the StackX community 2 years ago in 2019. So we invite you to join us, join our community through this meetup page. If you can scan the QR code here up on screen, you will be kept informed on the upcoming meetups, the events that we are organizing through this meetup page as well. Next, we'd also like to share about the Singapore Government Developer Portal. Next slide, please. Okay, Singapore Government Developer Portal. So the link is there. We invite you to scan the QR code. The portal allows us to publish the products developed by government. We have a wide range of products shared there. There's access to documentation for the products that we have developed, as well as community information, such as the videos that will be shared through the links on the developer portal after this event. So we are in our beta phase, and we ask for your patience as information is onboarded as we go along, and welcome any feedback that you have, if any. So just one last slide I'd like to share. If you're keen to hear more from our speakers, please stay tuned for our upcoming Takeaway event, podcast by the Data Science and AI team that will be released in Spotify in August next month. So speakers from our Data Science and AI division will share the challenges they face, the work that they are doing, as well as how it is to be a data scientist in GovTech. So please scan the QR code and follow us through Spotify. So without further ado, may I please hand the time over to Ivan. Ivan, over to you. Thank you.
Thanks, Karen. Hi, good evening, everyone. So I'm Ivan, organizer at DataScience SG. So for those of you that came over from our Facebook group, they won't need any introduction. But so basically, DataScience SG is a local community that aims to level up the local community for data science by inviting speakers from such as GovTech. So we're actually excited to collaborate with GovTech together to run this event. So the topic today is all about NLP, which is short for natural language processing. It's a subfield of artificial intelligence that gives a machine's ability to read, understand, and derive meaning from human languages. So we thought, by the way, if you guys want to see more of these meetups, please feel free to join our Facebook group, and we run events like this regularly, almost every month. So I'm going to give an introduction of our speakers today. So we will have Jason C., the Senior Director of GovTech's Data Science and AI Division, supporting the digital transformation of government agencies through the use of data science and AI to improve policy making, service delivery, and operations. So in his previous role at MINDEF, he led a startup of a new division which comprised the CIO office, the Corporate Development Directorate, the Data Science Department, and was responsible for the strategy and resource prioritization for MINDEF's digital transformation efforts. So he's also very passionate about innovation and challenging the status quo to make a positive difference. So after the kickoff, we will have the first half of the session. We'll have Watson Chua, who's a senior data scientist at GovTech. His interest in NLP stemmed from his PhD work in NTU back in 2008. And ever since then, he has been looking for interesting and impactful NLP use cases to work on, which brought him here to GovTech, where he can apply state-of-the-art NLP technology for the public good. So in his free time, he loves to run and has completed 6 marathons. In the next session, we'll have Jing, who's the lead of the data science team at Enterprise Singapore. When he's not programming or watching lectures from MIT OpenCourseware, he can be found running at East Coast Park or playing with his cat. So without further ado, I'm going to pass over the time to Jason to kick off the session. Jason, please.
Hello, yeah. Good evening, everyone. I'm Jason, Senior Director of Data Science and AI Division. A warm welcome to all of you all. Thanks for taking the time to spend this evening with us at this special Stack X meetup. Today's session is a special one. I think we are partnering DataScience SG to run it. I'd like to thank Chua and Ivan and their team for supporting the organization of this event. I'm sure many of you will be familiar with some of the key products offerings that GovTech has, whether it's in terms of SingPass, Live SG, for those who drive, Parking.sg, and then for parents with school-going children, Parents Gateway. And when COVID hit us, right, Trace Together and GovTech Safe Entry has now become part and parcel of our daily lives. And this is a very natural result of our GovTech mission that we aim to achieve, which is engineering digital government, making lives better. For the data science and AI division that I lead in GovTech specifically, some of you all may remember us for helping to catch the rogue train that disrupted the Circle Line almost 5 years ago. Okay, our data scientists helped to map out the raw data on a Mary chart using data tools to connect the dots. And in fact, Clarence, one of the data heroes, is still here with us in the data science and AI division, and he's still continuing to make significant impact in the public service. One of the products or projects that he's leading now is the core data infrastructure, where we have ingested various data sets across many different agencies, pivotal to supporting COVID operations, and of course, making the contact tracing operations a lot more efficient. In fact, this Clarence is still very busy, but he's going for his further studies in Imperial later this year. Masters in Computing, AI and ML specialization. We also believe strongly in investing in our people. The Data Science and AI division is also the capability center for data science and AI across the whole of government. Besides building central products and platforms, we also do data science partnerships with respective agencies and also push the frontier in terms of white space projects. But more importantly, right, there's this proverb that says, if you want to go far, we go together. We also invest significantly in capability development efforts to help uplift the competencies in terms of data science and AI for public service officers, as well as the data capabilities across agencies. And we also network with the industry and research institutions, and also like-minded people like you all in this community. In essence, helping to drive data science for public good. We started our Medium blog about 1 to 2 years ago, where we can share our experiences in terms of the full stack of things we do. Data science projects, data engineering, video analytics, our central platforms, products, capability development efforts, and the data transformation stuff that we do. So I welcome all of you all to go and take a look on our blog and to find out how we have been playing a part and a role in using data science for public good. This can include analyzing feedback on municipal issues, later we'll be sharing, using AI in the food industry, and our contributions to managing Singapore's water resources, just to name a few. This is beyond the route train and the COVID-related operations that maybe is better known. And these are, of course, just the tip of the iceberg. Many of the stuff we do might not be publicly shared, but goes on to benefit many government agencies that we partner, and ultimately benefiting Singaporeans and Singapore. So I'm very happy to be here. I mean, the meetup sessions like today, right? This is a wonderful, cool place. It's a great way for us to engage with the community, where we can perhaps share a bit more about what we do and also learn from you all as well. We welcome new suggestions, new ideas. Hopefully you all can interact a bit more later. And for those who are keen to find out more about our work, and because you also hope to contribute in similar ways to deliver data science for public good, do ping us, any of us, to chat, because we are definitely looking for good people to join our team. And on that note, I'd like to hand over the time to Watson, okay, one of our data scientists, for his sharing about analyzing feedback on municipal issues with natural language processing and deep learning. Enjoy the sharing and interactions for the rest of the evening. Thank you.
Okay, thank you, Jason, and thank you, Ivan, for the introduction. Okay, let me first pull up my slides. Okay. Okay, so I'm very honored to be able to come here and be given the opportunity to share about our work on building the analytics engine for the one service chatbot with the local data science community. So without further ado, I'll just go straight into the presentation. So the agenda for today, I'll first talk about the user, our user MSO, and then why they need a chatbot, and also the chat. So for the chatbot, there needs to be an analytics engine, and so I'll talk about the analytics engine's requirements, and finally I'll talk about how we build the analytics engine, and finally what the final product looks like. Okay, so this municipal service office is the agency that we are working with, and they work with public agencies and town councils to do two things: to improve feedback management and also to improve the service delivery for municipal issues. So all these municipal issues are issues that that residents are concerned with in their living environment, and also infrastructure issues. So for example, when you have things like you see bird feeding at hawker center, and you see potholes on the road, you see that the bushes or shrubs are not trimmed well, and or you see lampposts falling or not working, you can all report all these issues to the municipal service office, and they will work with the town councils if the area that this thing happening belongs to the vicinity that the town council is in charge with, or they will forward the case to a public service agency to take care of the issue. So it's tough work because residents make a lot of all these feedback, and most of the time there are complaints. They have complaints about any of these kind of cases, and they do it through the phone, the email, or the one service chatbot, and they have 130 cases per month. So that's a high volume. So some kind of automation will help them in better managing the feedback and the service delivery for all these municipal services. So since 2015, they have this one service app, which the residents can use to submit cases for like their complaints or their compliments for municipal issues. They can use this one service app to submit the cases, the feedback. So it's very convenient, and through this app, residents submit around 20 cases per month. So using this app, you can select the category. You can select the category, which is cleanliness. For example, you can select cleanliness and then high-rise littering, and then you submit the case, you type in your case, and after that, you put in the types of litter thrown, and then you give some description of the person who littered, and then you put in the location. So while this app is very useful, there are some imperfections. So firstly, the users have to manually select the case type. So this case type, the user might not be familiar with the categorization that this MSO has, so they might select the wrong case type. So for example, if they see overflowing litter bin, they might think that the overflowing litter bin is in the park or in the lift lobby area, they might think that it's a dirty public areas. And if something people throw killer litter, they might think that it's high-rise littering when there's another category for killer litter. So the users might have difficulties selecting the correct case type. So the second imperfection is that when the user types in their case details, so for example, you type in something like someone threw a TV console and a fan from some address, from which level, but after that you have to go and type this information again. So you need to type in again what's the litter thrown, and then where was the litter thrown from, and you need to put in the address. So this is the other imperfection, and we try to resolve it through our work for the analytics engine. And lastly, this one service app, if you are not a very frequent feedback provider, or you don't complain, you just there's only one single issue that has been bugging you, and you want to give the feedback, but you want to download an app for it. But if this one service app, you need to go to the Play Store or the Apple Store, you need to download the app, and then you need to install and take some time to download. So some of the residents, they don't want to do that, they don't want to download the app, but they have this issue bothering them, so they either make a call or they send an email. So how do we resolve this problem? So when you ask the resident, they only have to report one issue, and you want to ask them to report download the app to report issue, they'll give you this space. But if you say, oh, you can report your issues using your favorite messaging app, so they'll give you, yes, it looks good. So that's why we came up with the concept of the one service chatbot. So the chatbot requirements are that the resident can put in their feedback. So that's the text, and then they can put in their geolocation and their images. So this chatbot is hosted on Telegram and WhatsApp. So the chatbot will produce this output. So based on the feedback, it will give you the case type. So this case type is potential killer litter. So based on this case type, we can go and grab the template for this case type. So each case type has a different template. So we grab the case type from the template, and then we extract the information from the feedback, and we pre-fill the template with the information extracted. Then after that, the chatbot will prompt the user to fill in the info that's missing. And lastly, once you have all this information and the user has validated the case type and fill in the missing info, we use all this information to predict the agency which should be in charge of this case, and then we send it to the correct agency. So the flow looks like this. So the feedback provider, through the chatbot, it will send the feedback to the analytics engine, which my team is in charge of building. So the chatbot is actually built by another team, which is our Moments of Life team. So our my NLP team builds this analytics engine. So the feedback comes in. So we build a case type classifier to determine what's the case type, and then we return the case type to the user. So the user will validate the case type, and then we take the original feedback, and then we extract the case details from the feedback, and then we select the corresponding template. So we return the case details back to the user for validation. And then lastly, the user will send in additional images, geolocation, or whatever information they have to us. And that's where the conversation ends. So the agency classifier will offline, they will do this. They will predict the agency that's in charge of handling this case. And then together with the validated case type and validated case details provided by the feedback provider, we will send all this to the case router, which will forward them to the agency that's in charge of handling this case. So note that the agency classifier does the prediction after the conversation with the user has ended, because it requires additional inputs like geolocation and images, and it takes quite a while to process this prediction. So because of the chatbot has some time limit where it needs to respond to the user. We need to do this part offline, but for the case type and case details extraction, we can do it while the conversation is ongoing with the user. So next, I'll talk about how we train the case type classifier. So training a case case type classifier is a simple sequence classification problem. So where we take in the text and we take in the corresponding label, and we train a machine learning model to do the prediction on unseen data. So all these case types are logged via MSO's case resolution workflow. Whenever an officer closes a case or resolves a case, then they will put in the case type and the agency that it has been routed to. So from 2 years worth of data, we did some cleaning and we have around 166K cases. So we use these all these cases and their labels. In this case, we use the case type. So the agency will use it later for the agency classifier. So this time around, we are using the case type and the historical cases to train the case type classifier. So to train the case type classifier, we experimented with a few different embedding methods. So the first one we tried is the TF-IDF method. It's a very basic and traditional keyword-based method which has been shown to work well on a lot of data sets. So it's a very simple method which doesn't use any deep learning. So for this, after we use this to embed the text, we pair it up with we add on one linear layer output as well as one hidden layer linear output to see the performance difference. So the TF-IDF plus one linear output layer is our baseline model. So we want to see like this kind of simplistic model architecture, how well does it perform. Then by adding a hidden layer, how does the performance improve? Then for the next thing we tried, we use glove embeddings. So the difference between glove embeddings and TF-IDF is that TF-IDF, two different words with similar meaning, they won't have any relation. But for glove, because it's trained on a large corpus using the context information. So two similar words like car and taxi will have very similar embedding vectors. So when you say a car, when in your feedback you say something about a car, and then in another feedback you say something about taxi, then there will be some similarity between them. But the glove embeddings on its own is still not enough. So we added bidirectional LSTM and CNN to it to improve the embeddings, to augment the embeddings to take in contextual information. Yeah, so I'll go into details about this later. And then lastly, we use the transformers model called BERT, which so LBERT is a lightweight version of BERT. The BERT is the pioneer, the first transformers model that was created. So since then, people have been experimenting with different configurations and they created a transformer model called BERT, which has been shown to perform better despite being more lightweight. So LBERT, we use LBERT, and then we also added on one linear layer to show how the performance compares to the other model architectures. Okay, so the way we compare the case type classifiers performance is we did a 80-20 stratified train test split, and then within the 80% training set, we use another 80-20% train test split to do the hyperparameter tuning. We tune for the batch size, the learning rate, and the epochs. And for each of these model architecture or these configurations, we take the best of all these hyperparameter tune models, and then we show the accuracy, which is the total number of correct predictions over all the number of predictions made. And then because we are using the micro averaging method, so this is the same as the micro F1 score when we take the overall value. So we can see that in terms of accuracy, the baseline model TF-IDF with just one output layer and without any hidden layer has 72% accuracy, which is already quite high. But if we do add one more hidden layer to make it a deep learning model for TF-IDF, the accuracy increases by like 4 percentage points. So yeah, so there's some improvement over here. But by using the more sophisticated deep learning models with more layers, we are able to push it up to like 78%, close to 79%. So in terms of accuracy, I would say that this bi-LSTM CNN model and the LBERT model, there's not much difference between them because the percentage point difference is only around 0.5%. So both of them perform equally well. But in terms of timing, you can see that the TF-IDF based models, they train very fast, and Albert trains very, very slowly because it has billions of parameters inside which has to be trained. And BioSTM CNN is a good balance. It doesn't take so long, but it has good accuracy. And for inference time, you can see that the inference time for the whole test data set for BioSTM CNN, it follows the same pattern as the specific training time. So among all these model architectures, we chose BioSTM CNN because it has the best accuracy, and at the same time, it doesn't take too long to train on. We can make inference pretty fast, and the chatbot can get back to the user very quickly. So since we chose the BioSTM CNN model, I would like to explain a bit on how it works and how the configuration that we use. Okay, so when we take the words, so we tokenize them, and then for each word, we take the glove embeddings from the glove tree-chain corpus. So the glove tree-chain corpus embeddings have 300 dimensions. But these glove tree-chain embeddings for each word, the word is trained on the common corpus, but it doesn't have the information of our local corpus, local training data. So we added a 50 dimension, and we train another 50 dimension model using our training corpus, and then appended that 50 dimension to the 300 dimension from glove. So what this does is, for words that didn't appear in the original glove corpus, then we can also have a representation of it. The 50 dimensions, whereas the 300 dimensions will be 0 if it doesn't appear in the glove corpus. And also at the same time, this 50 dimension gives us the context of the words within our own training corpus. Our own training corpus instead of the commonly propped corpora. So we feed this into the BioSTM, in the LSTM model. So the LSTM model has hidden states with 64 dimensions. So at each hidden state will take in the embedding from the word itself and the hidden state output from the previous word. So for example, for upstairs, it will take in the information, the embedding from upstairs itself, the word embedding, and we also use the embedding that has been propagated all the way from someone from. So every word that we have over here, the context from the previous sentence up till now is captured. So this will change the word embedding, because it's, for example, a word like apple can mean, if you just use the word embedding, you will have the meaning of, it can mean the software company, or it can also mean the fruit. So if we capture the context which has been previously passed in, which we can augment it to take in the context of the sentence to be more representative of what it means within the sentence. So with this forward pass, we propagate it all the way through to the last stage. So traditionally, if you just use an LSTM model to represent the sentence, you will just take the last hidden state as the sentence vector and then put it through your linear layer to do the classification. But in this case, we are doing it a bit differently. So instead of just doing the forward pass, we also do the backward pass. So the same embedding vectors, we do it in the reverse direction. And then, so for example, this time around upstairs, the forward pass will have information from someone from an upstairs itself. Then the other direction, you will have bread, keeps throwing bread in the opposite direction. So this embedding from 350 upstairs, this embedding of the word upstairs from 350 dimensions, it has been augmented using the context of the local of the sentence itself to create a 128 dimension augmented embedding. So with this 128 augmented embedding for each word, we pass it through a convolutional neural network model. So we we group them into window sizes of 3, and then we do a sliding window, and at each window size we convolve it with 128 times 3 kernel, and then we get the dot product. So for those of you who are familiar with image classification or object detection, this convolutional neural network has its roots over there. So you will typically see something like that as a GIF. Yeah. So so this is a 2D convolution, but when you look at it only in one row, you can see how it convolves. So what the convolution does is it takes different combinations of dimensions, different combination of weights from dimensions across the three word embeddings, and then it creates it aggregates them to give a number for each window. So by having this sliding window and the convolution, we make the text, the 3 grams location independent. So regardless of whether this any 3 words appears in the center, or in the start of the sentence, or at the end of the sentence, they have some contribution to the final linear layer, and the final weights will be trained based on this. Yeah. So with this after this convolution, what we did was to do a max pooling and an average pooling to get 2 values per kernel. So in total, we use 64 kernels to get a 128 dimension embedding. So yeah, so that's the configuration we use. And lastly, we add the linear layer neural network to the end of the CNN output to get to learn the linear combination of weights from the sentence representation, which is the CNN output. So for each of the 1 to 8 dimension in the CNN output is fully connected to the output class, and then by feeding in the training data, the model will learn the weights for this data and also the bias TM model, and then we can get our fully trained model, and then after that we can use it to do predictions on unseen data. So we did this, and then we got the accuracy. So we got an 81% accuracy of overall accuracy on all the data, all the different case types. So 81% is good, but then because the data set is imbalanced, we observe some problems. So like cases with few samples generally perform quite poorly, but it's not always the case. So for cases which are very restricted to certain domains like abandoned trolley carts and national flag issues, so the cases, the domain is quite restricted and the scope is quite narrow, so it's quite easy to predict what kind of data will fall into these cases. So while most of the time classes with few samples perform poorly, it's not always the case, because some classes have little data, but they also perform quite well. Also, some classes have quite a lot of data, but they also perform not so well, because these classes encompasses maybe multiple issues. Like for car park issues, it overlaps with some parking issues and car issues and lighting issues. So they do not perform that well. But however, with an overall 81% accuracy, we are quite happy with the figures, and NSO is also quite happy with the numbers. So now that we have trained the case type classifier with 81% accuracy, we went on to train the case details extractor. So the case detail extractor, previously we were doing a sequence classification problem. So we use the sentence embedding, and then we train to see what's the case type. For token classification, each word has its own label. So by using the word-based case model, using a Hugging Face repository, and yeah, so this word-based case is by Google, we are able to train name entity recognizer, which is able to recognize things like rubbish, address, and things like that. So this is the word architecture where you put in an embedding, and then it uses self-attention to augment the weights, just like in BiasTM CNN, but it does so using self-attention instead of hidden state, so it's faster. And altogether there are 12 encoder blocks. So I won't go into details of what BERT is because I've only half an hour and it doesn't do justice to this sophisticated model. But I just want to emphasize that I'm using BERT for token classification and I'm using a case model instead of the Albert model previously because Albert is an uncased model, and for name entity recognition, usually capitalization plays a part in determining whether something is an address or other name entities. So we use a case model for this. So how we did this was that we asked MSO to help us annotate 5,600 feedback cases for us. So we set up this annotation framework using Tucano, and they just need to highlight and then highlight the type of litter thrown, the address, time of incident, and things like that. So this is the breakdown of the entity types that were annotated. So we put into the BERT model for token classification, and then overall we got an 86% accuracy. And the poorest entity type also has something like 73% F1, which is actually quite good. So we went with this model. And then we did some post-processing to extract the subunits of address. So for example, the address that we extracted were one long string. So we need to extract things like level and units from them using regex. And then we also need to remove duplicates and plural forms so that we can fill in things like type of litter thrown. So for example, if the person say he threw a fan here and the fan was so dirty, what color? So we want to have the fan repeated all across the place. So the post-processing takes care of that, and we have this template that is automatically filled and presented back to the user to fill in the missing information. So that's the case details extractor. So after this, once we have the case type and the case detail extractor, we go on to do the agency prediction to say which agency should deal with this problem. So previously we have already done a sequence classification using text. So this time around, we just need to add in more inputs to determine the agency. So the agency labels were also annotated by MSO when they close the case. So we put all this information, the text itself, the geolog, the image, and the validated case type and made them as features. So we use these features like the glove and glove, BioSTM-CNN text features, the distance to agency's land, and the objects detected, plus the one-hot encoding of the case type, and we feed them in a linear layer, output layer to train the model for agency prediction. So I'm going to details of this in the next few slides. So for geolocation features, we took the geolocation that the feedback provider sent to us, and we map it to the different agencies managed land. So we have this boundary map where we know where's the boundary of each agency's land. So we can calculate like this point, how far is it from HDB's managed land? Where's the nearest HDB managed land? And it is inside an MPark Spark connector, like in this case, the Plateau Nature Park. So it's part of an MPark Spark connector, the distance will be 0. And then also we also calculate the distance to various lands like PUB phase, HDB phase. So this gives us a 14-dimension input vector, which we can use as the geolocation feature. So this is all done using the OneMap API. So for image features, we use the you only look once object detection model, where for each picture, we see if this, so the users can submit like 3 to 5 pictures. So for each picture, we have a list of 58 objects, and we see whether each of these objects exists in the image. Also, we also try to find the distance of each object from the center of the image. So by default, the normalized distance is 1, which means it's very far away from the center. But if there's an object detected, then we calculate the distance from the center. So for example, this bicycle will be a distance of 0.33 normalized from the center, and the car will be something like 0.56. So across all the images submitted, we do a max pooling across all the objects for all the images. So if the bicycle appears in any one of the pictures, then we'll say that the bicycle exists. And then same thing for all the other objects. So for distance-wise, among all the detected objects, we take the smallest distance from the center. So for example, if bicycle appears in one image very close to the center and very far in another, then we will take the minimum distance from the center. So each of these, there are 58 objects, so there will be 58 dimensions. So we took the 128 bias CNN embeddings, then take the geolocation features, 14 dimension, and the object. So we have 58 for that existence and 58 for minimum distance. And then lastly, we add the one-hot encoding of the validated case type 62 dimensions, and we train it with the agency data inside, and then train the model to get the weights. Then there we have our trained agency classifier. So accuracy-wise, it has 87% accuracy, and the F1 scores for the top 6 agencies are actually quite high. So it's all 85% and above. But same as the case type classifier, it suffers from the problem of imbalance classification, imbalance data set. So some of the classes with fewer samples will have poor accuracy, poor F1 scores. But the good thing is all the top 6 types covers 96 of the cases that were handled. So we are safe with that. So for the remaining 4%, can let the live agent deal with it. It's a bit imperfect, but it works. So I would also like to show like what's the impact of adding all these different input features to the text. So initially when we did our case type classifier, we only use text. So if we have only used text, we will have got an accuracy of only 81%. But if we add images, we have a marginal increase of 0.03%. But if we add geolog, then we have quite a significant improvement. And if we further add on the case type, we have even better improvement. That's because this geolog sort of determines whether which agency should handle a case based on the land that the agency owns. So remember just now I showed the one map API where we calculate the distance from each agency's land. So if it's near or inside an agency's land, it shows that it gives added weight to show that this case should go to that agency. And also there's also a distinction between town council and agency. So if it falls within an area that should be taken care by the town council, then we will classify it to ask the town council to take care of it. So the case type is adding a case type. Having improved accuracy when the case type is added is expected because the case type like high-rise littering or illegal parking in HDB car parks, the case types sort of like closely correlated to the agency that should handle it. So when we add in that information, provided that the users validate them correctly, we are able to add quite significantly to the F1 score, to the accuracy when we include the case types. So to recap, we wanted to build a case type classifier, a case details extractor, and an agency classifier for the chatbot so that the users can submit their feedback and then get all these template automatically filled and the case routed to the agency. So we managed to achieve 81% accuracy for the case type classifier, 86% accuracy for the case details extractor, and 87% accuracy for the agency classifier, which is quite good. And so we deployed it, and then this is the final product. So you go on Telegram or WhatsApp, you can type in the case that you want. So it's a bit small here. Let me read it for you. So they will ask, the chatbot will ask what happened. They will say, neighbor upstairs, blah, blah, blah. At this address, like to throw leftover food out this window. So it happened today, 3rd of July at 2 p.m. So they will predict the case type and then ask you to confirm. They will say yes. And you'll pull up the template, and then they will only ask you the questions that is not filled in the template. So in this case, the description of the offender needs to be answered, but we didn't provide that information, so you ask for it. And then also where the litter was thrown from, which we didn't give. So at the end of it, it will show everything to the user, to ask the user to validate the information. So note that all this information that was previously entered wasn't displayed. Wasn't prompted. So the user don't have to repeatedly answer those questions that he has already provided information for. So this bot will be launched next week. Yeah, just look out for the announcement. So lastly, I would like to acknowledge my teammates from the GovTech team in AI platforms who have been working with me on this analytics engine, and also MSOs officers who have been doing the data annotation and project management and working very closely with us. Same thing for the Moments of Life data team who has been doing the chatbot development and doing very good work in doing the integration between the chatbot and the analytics engine. So that's all. So I would like to thank you for listening to my presentation. But if you have any questions, you can ask them at the end of after Jing Song's presentation, where we have a Q&A session, or you can type in the Q&A panel. And if you haven't read this blog post, you can scan the QR code and go to this site where I write in more detail of what I have done for this MSO chatbots analytics engine. Okay, thank you. Once again, I'll hand over the mic to Jing Song.
Hey, hi everyone. Yeah, Jing Song over here. Let me try to get my slides up. Right. All right, okay. I hope everyone can see my slides. Okay. Okay, sorry, Karen. Yeah, can people see me, my slides?
Yes, can see you now. Thank
okay,
you.
Great. Yeah, hey, guys, thanks a lot for the time. Attendees here, and I think the DSSG organizer. So my name is Jing Song. Short intro about me. I am part of GovTech's in-house data science team and serving the specific agency called Enterprise in Singapore. So unlike Watson is in the central team and he builds on products. So we have central products like Trace Together and the AI engines that Watson is building. And we also at GovTech have teams that are dispersed throughout agencies. So I'm part of one of the sites we have at Enterprise Singapore. And it's Enterprise Singapore. It's doing a lot of interesting work and important work as well to help out local companies. And I enjoy running. I enjoy programming, and of recent I enjoy spending time with my cat. So that's about me. And I will share my experience. So this will be about 20 minutes. The first 10 minutes, I will share very quickly about a simple NLP workflow used for sentiment analysis. So some of you on this call are technical. We won't get into as much depth as what Watson shared, but it's really just a workflow to give you a flavor of the kind of pilots that we do at the sites, and eventually we want to grow them. It's another story. And after that, I will also spend 10 minutes just talking about my time working in an in-house data science team, because we have quite a lot of positions that are open. And after that, we can just all stay back for Q&A, some chats and all. Yeah. Okay, so firstly, intro to my teammates. That's me over there. It's a very small team. We only have a team of 3 people. The second person on my team is Shane. Don't know whether he's in this call. And the last person, he's Jovi. Don't know also whether he's in this call, but Jovi is involved in things like the COVID operations that Jason shared about, cobbling together data. You can just imagine the amount of data we have in the background, and for operations like contact tracing, it's no mean feat, just working through the data. Okay, So I will now start off with the business case that that leads to this NLP workflow. And I always think that the business case is one where you start figuring out what is signal and what is noise. And I think that that's a central problem of data science, right? You have a lot of information out there. You have pictures, right? Multi-dimensional data. You have text, right? Once again, many dimensions, right? It's not very neat data set. And it's very noisy. And it's always how do you tease out the signals from all the noise? And in GovTech's case, it's teasing out signal from the noise to enable government to do its job better to improve the lives of the public. And so that's a problem I face at ESG. That's a problem Watson faced. There's a lot of noise, I think, when it comes to MSO chat and just about teasing out the signal to do the classification. I'll now talk about the situation where we have CRM, we have emails, and we are receiving a lot of text information, and just a very simple prototype NLP workflow to tease out a signal from the noise. So imagine this is a chat, right? One fine day, I get a note from my ESG colleague, right? So ESG is my client agency. I say I can't quite figure out how to segment my companies or my clients. I've got email data, I've got CRM data from about 3 years back, and it's quite a bit of data. In CRM, maybe we have about 3,000 questions coming in a month. Emails, even more, maybe 30,000, right? Yeah, we want to try to figure out how do we make use of the data. And I think the immediate question is not, okay, let's come up with a model and let's start experimenting with it. It's more of, so what kind of business response do you actually want to do? It's not data science for data science sake, right? You're not just trying to use a model for the sake of using the model. So how do you want to respond to the clients, right? These companies, let's figure out a bit more so that we can build a process, a workflow that actually delivers business value and helps you do your job better. In this case, for me, it's about understanding companies and really helping Singapore companies through some difficult times now. Well, the person may say, I want to respond more proactively. And what's more proactively? It could be the situation where if some of our companies are more concerned about some financial related things like loan restructuring in a certain industry, and I want to deploy more financial advisors over there so they can understand how to restructure their loans, how this government initiatives actually can benefit them, right? It also may be the case that some of these companies are having trouble digitalizing, right? Moving towards e-commerce and all. They may need some kind of guidance to things like just workshops, right? You get people together and you work through things with them. Not every company necessarily is populated by digital natives. And so as a data science team, you say, okay, great, let's start. Let's figure out what happens. So the outcome to achieve is this. We want tagging. We say have 3,000 queries coming in a month, and that's considered noise. We want to get signal from it. So how do we get signal from all the noise? You get a text that says, I'm worried my employees cannot work from home. They don't use their computers much. You want to tag it as something like digitalization, right? So this is a type of query. Then another one is I run a shipyard, right? I'm one of the shipyard vendors over there, but I really can't manage my shipyard operations, right? My workers are not coming in due to the travel ban, and also my loans are expiring, right? So maybe it's tagging as a cash flow problem, it's tagging as a labor problem, right? And these are things government wants to keep tabs on, right? When it's making broad level decisions, strategic decisions as to what to do, right? And then there may also be questions, right? We typically get these, right? Any grants, right? Any money for us, right? And then you may want to tag it, okay, maybe this is not something that we really want to watch or we really kind of have a whole work stream for that. So we'll just tag it as others, miscellaneous, right? So this is kind of the tagging you're looking at. And once again, you have noise, which is about 3,000 queries coming in a month, and you want signal. So signal is just about simplifying the noise and trying to represent it in a way so that it can take business action. And then you may want alerts to say like digitalization, it's rising, and then cash flow, the concerns are decreasing, and labor concerns are increasing. So it moves in it. It's about taking the noise and it's about simplifying it to something that then our users can take action on, right? And essentially that's the work I do. I think that's the work that a lot of people in data science teams do. So that's all we are doing. Well, Well, this may seem pretty basic. One can just Google any Medium article and sort of figure out the workflow. There are some interesting parts to this problem I want to share. The first one is a cold start problem. Assuming you have a corpus, say, I don't know, like 100,000 business queries, which I receive on questions from the business. We gather them from our CRM, we gather them from our emails and all. How do you start tagging them, right? It's a cold start problem, and what do you do about it? So what we decided to do was to first have the conversation with our business users to give us the categories. So we don't go in there to do an unsupervised learning. We want to do supervised learning, tapping on the business knowledge, the domain knowledge of our agency colleagues. So we ask them, give me the categories that our agency, that government is most concerned about and that government can take action on, right? So it's about having that conversation, because I'm only a data scientist, right? Like I can sit in front, I can work with data science models, I can read papers, but really to understand the business of government is a lot richer than that, and the public service is 100,000 strong. So then the business users will give the categories, right? These are all the actions, the levers government can pull, the policies in order to make sure our local businesses succeed. Then after that, the business users will define terms to include and exclude. So for example, they'll say, oh, digitalization, these are the terms we want, and these are the terms that are kind of like anti signals. We kind of don't want them inside. And once they define this, you then can start something that's rule-based, right? In this case, it's just very simple. You just create a regex, right? And just based on the rules specified by the business user. But the trouble with rejects, as all of us we know, is that there's a problem of underfitting, right? People may say they have issues with loans, but what about other kind of similar words, right, that reside in the vicinity of that word? Semantically, they may be a bit similar. So that's the problem of underfitting there if you just use rejects, and all of us should know that. But using rejects, though, you can solve the cold start problem, or at least my team experimented with that. You have the prelim categories, right? So now you have prelim categories just based on the rules. And then the business users can validate about 30% of the output. 30% is just a ballpark over here. It could be 10%, it could be 5%. But it's really about trying to use a rule-based method to kind of just provide the first cut filter before you get the business users to actually do some kind of validation. And then from it, the business users will validate like this, and they'll validate, oh, category predicted versus category validated. They'll just fill it in, and they'll highlight words that are key for them. And these all from your training data. You just keep them, they are golden. You want to make sure that your model actually fits around these validated data tightly, and then you output the training data. So that's about solving the cold start problem. And once you have the cold start problem, it's really just the basic stuff, right? I won't go through it. It's not as in-depth as Watson. I think he had a more sophisticated way of treating it. But at my team, pretty small, we deal with multiple use cases, some pilots, and we decide what pilots goes to production and on. So usually when a pilot happens, as was this case, we just take it, we run with it, we see what happens, we go back to the user, we reiterate iterate with them. So you clean. You do dimensionality reduction. So I don't know, like how many words are there in the English dictionary? Tens of thousands, right? And then you reduce it. You can use glove embeddings or any other kind of embeddings. And after that, you put it through a neural net, right? Over here, we use just a very vanilla LSTM. There's nothing fancy about it. And so that's what we do. Over here, I noticed in some of the questions, I thought some of the comments were especially sharp. One of them was actually how much time you spend cleaning. I think that was really addressed to Watson. But on reflection, if you were to ask me how well did this whole process and model perform, right? And so we have the training data, and then we hold out for the test data, and then we run through it, right? Clean dimensional reduction LSTM, using a combination of rejects and also the validated data to produce the model. The step that actually gave us the most lift, I can't give you the percentage points right now. The other people in the data science team understand the metrics a bit more. I'm not the one to give you the specific metrics, but cleaning actually gave the most lift to the model, got us to an accuracy of a bit above 80%, but it's really the cleaning bit, understanding the text, looking out for anomalies, and then when new text come in, noticing things, whether or not there's any feature drift and all that. So yeah, the cleaning step was really important. Okay, so that's the training data. So you have the categories. You are able to say, okay, digitalization, trend is rising, cash flow issues, people are facing more issues, or labor issues, right? The general sentiments coming in, and you can label and tag them, and then you can slice and dice by industry and all. So we go back to the client and we are pretty happy about it. And client say, oh, this is useful, thanks. And so now the client is taking some actions back and behind the scenes. They're having discussions within government. This is what we need to do for our local businesses or some kind of targeted help thereabouts. But then there is this category called others, right? And the person may just say, okay, this category got me thinking, are there topics of interest, right? So it's unsupervised learning now. And it's not just topics of interest. I want those that are emergent. So I don't just want anyhow topics. I want topics that are hot at this moment or getting hotter, so I can sort of understand the trend. Once again, it's about signal from noise. You get a lot of queries coming in and you want to tease out signal based on whether or not it is not just popular, but how popular it is over time, right? Whether there's something increasing, right? And so that's what the word emergent actually suggests. And so it's kind of like a forecast, right? That they want to look into for these things. So as a data science team, we say, let us see about it. Then we're just like, okay, we have to spend a few days this week thinking about it. So then we get to this point about finding emergent topics. The base model is really topic modeling. And I think maybe 99% of you on this call will need no explanation about that. But I thought what was interesting, or rather, I wouldn't call it novel, but I thought on the team, we spent a bit of time thinking and talking through. It's really about how do we use a sliding window to do topic modeling to really bring to life this request from our users about finding not just topics, but emergent topics. So we do a sliding window. So assuming you have a 3-month sliding window, you do topic modeling over different windows. And what happens is if you take topic modeling over the last 3 months window, you can actually take the resulting matrix and basically impute it on previous windows in order to actually get a trace as to whether or not the topic you had found in the last 3 months were actually getting more popular, right? So this is just a very simple representation of the linear algebra behind it, right? The document term matrix, right? For the specific sliding window. So it's the last 3 months. So we just focus on the last 3 months. You put it through the topic model, you get out the term topic matrix, right? And what happens is with the term topic matrix you have got from the latest window, you can actually impute it over the previous windows, right? So for all other windows, right, the previous windows, preceding windows, you can actually do it. And you actually find out what are the trending topics, the topics within the last 3 months, and how do these topics within the 3 months relate if we had to kind of backward impute it across the different documents. And then in so doing, you perform some kind of unsupervised learning, but you also show the client what exactly is emergent, what is increasing, what's decreasing. So it's not just what is the most important topic, but actually is this an issue that is getting more important over time, or rather novel. Yeah. So putting it all together, it's a pretty simple workflow, and that's what I'd like to just share with you all my experience today. Firstly, it's about solving the cold start problem. It's about having the business conversation and solving the cold start problem. The next part of it, it's really about the vanilla bit of building classifier. You clean it. And once again, my realization, cleaning is the most important step. Dimensionality reduction, and then you put it to a neural net. In this case, it's LSTM. And then after that, after you build a classifier, for those that are not classified, you actually put them through the emergent topic pipeline, right? And then you get emergent topics. And then from it, you can get some kind of scorecard of sort of like key issues and how they are changing across time. And then business decisions management will make decisions based on it. And once you get emergent topics, another part of this workflow is actually promoting some of these topics that you have picked out from an unsupervised point of view into categories, which will then place it in the supervised workflow. So something that I've learned just from this experience, it was this prototype that we built. It's really about how the interaction between supervised and unsupervised. And sometimes when you find something that's unsupervised, after a while, from a business point of view, the business may say, actually, as opposed to just looking at your unsupervised model, I think that this is an area that we really wish to carve out as a category that we wish to monitor. And then in that case, we just have to find a way to promote it into a category, into our supervised workflow. And as you can imagine, a lot of the effort, I haven't shown it, but it's really about the organization of the data sets. I think there is a growing field called ML Ops, but I really think it's just about being super organized with the way how we work with data, how we store the user input, and how we evolve the whole workflow and the different models along the way. So that's about all my sharing regarding the simple NLP workflow. For the next part, I'm going to switch gears. I'm going to switch gears and just share a very bit about my experience in a forward deployed data science team in GovTech. This will take about 5 minutes. But the reason why I want to share it, it's because I think, as Jason mentioned, and as you would see in the slides, in GovTech we have good people, and we are always looking out for good people, if not better people, to join us. So yeah, so this is the excerpt of a JD, and I have 4 reflections to share. These are non-technical. I apologize if you are just looking for something that's purely technical, but I thought of just sharing my experience. So if any of you are actually contemplating making a jump to GovTech thereabouts, yeah, we can always stay and have a chat after this as well. So this is the JD for team lead for forward deployed team. So it's a bit different from Watson, where he shared about the central team. Central team, they have amazing data sets and they build central products as well, but we also push out people to different agencies. And the reason why we push out is number one, for business reasons, right? When you operate at a distance from your different agencies, I don't know how many agencies are there within government, right? You have law enforcement agencies, and you have economic development agencies, you have social agencies, you have the environment infra and all that. It's pretty hard sometimes to understand their business cases. And I think most importantly, it's about building trust, because sometimes it's all these casual conversations that used to get in the lift lobby when we are back in the office and all, where you actually pick up opportunities where we can actually use data, where we can use technology to really improve things for citizens to the agencies. So it's about trust. I think when you're forward deployed, you get to build that up a lot. And also at the same time, this whole business process is about making sure that when you run data science projects, you deliver impacts and you know how to close projects. So there's a bit of PMing and skills involved in it. And yeah, even as people in the data science track, I think there's a bit of recognition that these PMing skills are actually pretty generally useful, and centrally within GovTech, they do provide that level of training, that level of mentorship to help us out, even as a forward deployed team. The second thing really I want to mention is about analytics, right? Which is what most of us are here from. It's about teasing out the signal from noise, talking about growing data science capabilities, turning data into critical information, data cleaning, pre-processing, feature engineering, and all that, right? So my own reflection is that increased standardization helps, standardization of your scripts. So I'm increasingly thinking whether or not people should be developing both Python and R, or whether you should just standardize everything to Python. And then you find a way to modularize your script so that components are reusable, right? It's just a whole idea about being lazy rather than reusing things. So I find that conversation going on around analytics. I also, on the softer bit, right, it's about working together with the agency colleagues whom I'm deployed into, and building their capabilities along the way, right? Because, I mean, for instance, I serve this agency called Enterprise Singapore, and they have some pretty good officers who are, and by good, I mean good at analytics, right? Like they can build dashboards that bring to life data, and some of them are trained in statistics as well, but they are involved in more business-facing things, like crafting out grant policies, or maybe a regional director in one of the overseas centers and all. So they're really interfacing more of the business, but they also know analytics as well. So it's not just about the small data science team doing all the work, but really it's about working hand in hand together with them. And you really get the flavor of it when you're deployed out there. The third of 4 reflections, it's about IT systems. It's a small team, right? Just the 3 of us, right? And if you want analytics, not just to, I don't know, it's not a Kaggle competition, right? It's about giving something that can then integrate with the business flow or the IT flow. You can't run away from software engineering. It's kind of fun. Software engineering is pretty fun. It's kind of frustrating as well, but anyway, I mean, that's just IT. IT's been that way, I guess, for decades. And it's really just about learning on the job. And we really work together with the in-house IT team as well. I think GovTech has a stronger presence within each agency beyond just data science. Working, for instance, tomorrow I'm talking to the solution architect about like authentication, authorization, and architecture. Where should we actually put it as we modernize our stack? So yeah, you do get pretty lot of exposure to the IT systems too. And the final bit really is just about people. I think I've been at GovTech DSAID for about I think it's approaching 2 years. It's very, if not the most rewarding bit. I like the team I work with, and I think that's a bigger team at GovTech DSAID, or in fact the whole GovTech as a whole. And generally have good folks. So it's been a pretty rewarding experience. And yeah, so that brings me to the end of it. The NLP bit was a bit less technical than Watson's, but I'll end over here. Once again, I think just to be very paise about it, we are recruiting. Yeah, thanks.
Hi, okay, thank you both Watson and Jing for sharing both technical bits and the not so technical bits, especially about the culture and all the different problems and challenges associated with trying to deploy a data science solution, right? So we're going to go straight to our Q&A now. We have a ton of questions. We will try to answer as many of them as possible until 8:35. So I'm going to go right. The first question, anyway, both of you feel free to chime in. Some of the questions are directed at specific projects, some are not. So the first one, okay, so Yi-Chen asks if there are any attempts to build an open source Singlish BERT-based dataset or model for purposes of adapting pre-trained word vectors to the local context. I did a quick Google. I actually found one that is literally called SingBERT. Don't take my word for it. I haven't tried it before. So, what are your thoughts on it?
Yeah. Okay, so for this BERT, Singlish BERT, yeah. So the one that you mentioned, SingBERT, built by Jing. So I also reached out to him on LinkedIn. I've tried his model. It was he collected all these hardware zone forums, chat, and Reddit Singapore chats. Then he trained the BERT model based on it, and it was quite good. So I've actually tried some mask fueling and also sentence classification, sequence classification using his model. So it is able to represent the Singlish text quite well. So what we would do, I mean, so all these Singlish text is also occurs in all the feedback text that we are given, and with this Singlish trained BERT model, it will definitely help in improving our accuracy. So what we would do in future is, instead of training them from scratch, we will just take this model from the Hugging Face Model Hub, and then we fine-tune it further by using our own data sets. And also we intend to collect more, other than Singlish BERT, we also intend to collect more government resources like internal circulars or those circulars memos released to the public and things like that, and information from government website to build a government BERT which is able to understand and represent government lingo. So government BERT is in the plan, but we haven't really thought of who
name for it.
Yeah. That's right. Yeah.
Okay.
But SingBERT, we won't do it from scratch. We will just try to build it off the SingBERT that Zenlin has built. And also we might use some of these feedback info that we have to further fine-tune it. Yeah, just a note that I think there's some other questions which talks about Singlish or local lingo. Just want to note that the feedback that we receive, they are most of the time they are some of them are in good English, but a lot of times they are in broken English, but they are not really Singlish. So that's why even when we use GFIDF, which is sort of a back of words approach, it still works pretty well because it's broken English, but the words are still in the vocab. It's because when people send in feedback, they know they're talking to a bot, to an app, or even a customer service officer in MSO or an agency. They won't really use a lot of English like "japa boy" or "tak boleh tahan" or things like that. They will still try to use English, just that it's broken English. So there's a distinction between broken English and Singlish. So for Singlish, it's sort of like a spin-off language of its own, with its own vocab and grammatical structure. But for broken English, it's still the English model could still deal with it pretty well, which is why we didn't really use Singbird for all these municipal issues feedback. Yeah.
Okay. Thanks for your answer, Ichan. I hope that answers your question. So I have another question. So probably this can be directed to Jing Song. So Li Han asked, what would you say is the most technically challenging part of your whole project? It'll be great to see how your team overcame them and whether there are actually new or interesting things that you've learned along the way.
Right. So for this specific NLP project, I would say the most challenging thing that we will be working with is actually on the software engineering bit. So once the models are done already, I mean, you kind of just have a workflow out. But just getting the data flowing, making sure it's modeled correctly, and then serving out the information, that would be the major efforts. But I mean, if you want to just look at purely on analytics bit, there are many interesting problems beyond NLP we are looking at. If I just say some people are looking at like graph problems, you can just imagine that government has quite a lot of data relating to relationships, company data, and more. So yeah, there are some very interesting analytic problems that we are looking at. I think it's pretty cool, but it's not related to NLP per se. Thanks, Ivan.
Yeah. I would say most of the problems or challenges actually come when you try to productionize the model, and then you realize it's not as straightforward as it seems, right? So, okay, the next question I think is with regards to Watson's project. So Sheng Ong asks, what happens when, I think this is related to data quality issue, when the data conflicts with each other. For example, your case details, images, and case types and things are actually wrong.
Okay, so what we did was we put all these different features and then we add on a linear output layer to it. So by training with a lot of data that is in our historical database, the linear model learns the linear combination of weights across all these dimensions. So it will learn to prioritize some features over the other. So even for a particular case, if the data conflicts with one another, so for example, it's something like he described something which is a rubbish bin issue, and then he submits a picture of a cat, then it will depend on how the other data is like in the data set. So if the other data in the data set, the text features are more prominent and the weights for them are higher in the linear combination layer. So we will take more, we'll put these text embeddings as we'll weigh these text embeddings higher, and they will have a higher weightage over the images. So the conflicts will be overridden if that's the case. Conversely, if the image one has a better accuracy in the other in the data set, the whole data set, and then the converse will happen.
Yeah, so basically it goes in the details of fine-tuning the model, right?
Yeah. So
okay.
Right. Yeah, that's
okay, so the next question probably for Jing Song. Priscilla asks, is a cold start issue something that's very common for forward deployed data scientists?
Yes, it is important. Yeah, and not just that. I think it's about how a lot of the data is not labeled, and it's just about having a process to label it. So not just for deployed teams, but we also have computer vision folks in GovTech DSAID. I mean, the ones catching PMDs, catching cigarette smoking and all that. And so actually a lot of the effort is spent on coming up with a structured process to label and to really solve the cold start problem. So yeah, yes to your question.
Okay. I have another question here, which I think either of you may take it or both of you may take it. So this question comes from Adam. He asks if, do you think there's any value in visualizing the vectors that are created by GloVe in a way that the wider population can look at, for example, in 3 dimensions at a time in a vector space so that they can get a better understanding that the fellow citizens experience?
Okay, so the problem with visualizing data of a very high dimension is that you need to project down into either 2D or 3D in order to visualize it, because the human brain and human eye can't really visualize more than 3 dimensions. So, but when you project down, then there are some information loss, because typically a GloVe embedding is 300 dimension, or in my case, I use 350, and the bird embedding is 768 dimensions. So to project all these down to a 2D or 3D canvas, then I'm not sure how the visualization will actually turn out. So yeah, so we haven't really tried that, so can't really answer you. But what I know is that for bird Hugging Face, they have this sort of like a model debugger where you do your pre-training on some data, and then you put in and they show you like the vocab, and you put in a sentence, then you click on one word, then they'll show like the weights and the connections to some other word. So that sort of help in achieving what you want, like how the self-attention works, and how you are able to debug it and look out for any bias in the training data and things like that. But for this specific case of looking at all these trigrams and how they interact with each other through projection and visualization, frankly, I'm not very sure how it will work out.
Okay, no worries. Actually, I do have an opinion on this. I agree that I happen to have worked on this before. You can use TSNES or PCA to reduce the dimension to 2 or 1 to visualize. It actually works quite well, but you're right. There's a lot of information loss in that process. So okay, I'm going to move on to the next question. There's a lot of questions, so I'm okay. So there are a couple of questions related to imbalanced data set. Either of you can take it as well. So Insio asks if you have tried gradient boosting classifiers to solve the issue, and in reality, how do you actually mitigate issues related to imbalanced data sets?
I think so. I'll take that if you don't mind.
Yeah, please go ahead.
Okay. So for the MSO, actually not just the MSO, a lot of agencies data that we work with has this imbalance problem. So, and the imbalance is not like 70-30% kind of imbalance. It's very severely imbalanced. Like one class will have maybe 100 and another one will have like 40K. So this creates an issue, because if the model predicts everything for the majority class, then you have high accuracy, but when you look at the individual classes, a lot of them have poor F1 scores. But for our case, we see that this isn't exactly happening, because like I showed during my presentation, some of the small sample classes still have quite high accuracy. And the way I try to deal with the imbalanced data set problem is I try to oversample the smaller classes, but the overall results didn't turn out too well. Yeah, and I also tried. I wanted to try things like smooth, where you have you use the nearest neighbor and then you try to take something, the three nearest neighbor, you take some feature in between and to try to create fake data to boost the samples. But I read that it doesn't really do very well for NLP text data because of the high dimension. And in reality, when you do this kind of things, it's like you are creating fake samples which don't really reflect what the users feedback, actual feedback are. So I'm not sure if that's the way to do with data, because you create some fake samples, then you get the better accuracy, but in reality nobody types like that, gives feedback like that. So that's just going to boost your score, but in reality it's not doing anything very well. So what we intend to do with the imbalanced data set is for those classes small classes that we have, you just let the system run for a while, and for MSOs and let them collect more data. Some of them may be because these are some new cases, or for example, safe distancing is a new case, but it has a lot of data. For example, like mosquito breeding, sometimes it's quite seasonal and things like that. So we let it run, then we collect more data, and also we also try to look for alternate sources of data, because right now the data we're getting is from one service app. So if we can collect from other agencies which have this kind of data, feedback data, like maybe the Ashemi chatbot, or maybe from emails and transcripts of phone call, we can supplement that data in the small classes with all this data to make it more balanced. Yeah.
Yeah. So
sorry, Ivan, can I jump in over here and really ask you and
Sure.
Watson a question? I know you're supposed to, but I thought the imbalance one, it's so I think I'm fairly I'm newer to this data science discipline than perhaps both of you are. Can I ask, what are your views about creating synthetic data, like using GANs to create fake data to kind of grow your data set? So I guess for Watson, what I hear is that you specify metrics per category level to kind of prevent the situation, I don't know, where you just predict everything to 40,000 and then 100 suffers. But what about you mentioned something about synthetic using GANs, and I heard from this A-star researcher that's a possibility, but I wonder if even Ivan, whether you have any views on it.
My thoughts are same as Watson. I don't believe in creating synthetic samples. It usually doesn't turn out well. But I mean, if you have a severely overly balanced data set, like what Watson said, if you have the luxury to go and collect more data, then that's great. If you don't have, usually the only solution is oversampling, undersampling, or tweaking the model to penalize certain weights in the one of each of the unbalanced classes. So yeah, no way around it. So yeah, I think we are going to take one last question. We're going to wrap up in 3 minutes time. So yeah, again, either of you can take this. This might be a good wrap up. Let me find the question. So this is from Christopher. This is sort of related to data scientists in GovTech. So he asked, based on your experience and skill sets, is there a path from data science to ML, or do you think that these are two distinct groups of folks with like totally different skill sets, and whether you need to retool to move? For example, if you know how to run a very classical regression model, does not mean you have the skill to pick up DNNs immediately.
Okay, maybe I go first, then Watson can come in over there. So I know within GovTech professionally, there's actually a lot of attention paid about carving out specialization tracks. And I think the DSML track, from where I stand, so I don't the high ups. I don't think there is that need a distinction. But I actually understand where this question is coming in, because the ML deep learning space is actually moving deep into specialization, and there's somehow a bit of divergence for me for your traditional stats and econometrics and all that, right? It's a bit funny because I was talking to somebody younger who just graduated. I think he graduated from Stanford, and then he did some deep learning stuff. I was just like, yeah, you know, to like for the selection test, you know, like stats and everything I'm plotting. Just like, oh no, actually what I did with most of professors for most of my summers were just taking data and smashing into neural nets. And that was his point. Yeah, so I really can't comment much about it, but I sense where the question is coming from.
Okay, so from my point of view, I think it's from okay. So the question is about that path from data science to ML. So I think these two fields are like these two domains are like really closely related. It really depends on which product team you are in or which maybe forward deployed team you are in. So some of the teams they work with things like text and images and they have annotated data. So for all these kind of roles, you would need to have some ML skills. But if you are working with some other in some other fields where the data is not really annotated or it's not text or image and there's no established machine learning field in this, then you might not really be able to apply all these machine learning techniques. And as to whether you can being able to run regression classical ML models versus and how does that lead to being able to do the end-ends, right? I would say that with modern repositories and libraries, the way you run this classification using deep learning and more and transformers, you don't really need to know what goes beneath it. So like for example, Hugging Face transformers is a very good example. You just need to look at the tutorial, learn how to prepare your data and then call all the correct model and download it and then run it through and then do your find your metrics and then do it. Of course, with the right skills, if you understand what's going on underneath, then you can know why some models do well, but once some models don't do well. But I think those stuff you can pick up through experience.
Okay, yeah, basically to sum up, right, like I think it's no issue to transition because once you figure out how to do the evaluation, they're all the same. The model wise, they are all developed by research scientists at some of the top institutions. So we are really just riding on the shoulders of the giants. So you just need to have an intuition of like how it works, but not really into the math. So we have a ton of questions still open. So probably y'all can answer. We'll take the time to answer them via text. So we'll be moving on to the networking session now. So Karen can take over from here.
Okay, thank you, Ivan. Thank you to our speakers, Jason, Watson, and Jing Song, and Ivan for moderating the session so well. We invite you to share how the session went by scanning the QR code that we have brought up on screen. Please tell us how we did and how we can do better. And also, if you have questions for our speakers, we invite you to join our StackX Telegram community chat, the QR on the right side. And finally, if you're keen to explore some of the data science and AI job openings, we will be sharing the link in the chat shortly. So finally, we will be opening up the session for the speakers networking. The speakers will be staying back to answer further questions that you may have from the session or how it's like working in the data science team. For this session, we invite you to raise your hands if you would like to speak, and then we'll unmute you. Otherwise, thank you for joining us, and we hope that you found this sharing interesting and look forward to welcoming you to future meetups as well. Thank you, everyone. Let me see if there's anyone who's raised hands. Does anyone have any questions or would like to chat, or please welcome you to raise your hands.
I think everyone is very shy.
Yeah. Okay. If you all prefer, we welcome you to join the Telegram chat, and maybe you can type your questions, and the speakers will be on through the Telegram chat to answer some of these questions as well.
Yeah.
Yeah. I've also shared the link to our Telegram chat. So it's a very valuable chat actually, because you will know when we upload the video on demand. Yes. Oh, Shiraz has a question. Shiraz, do you want to speak and just have a quick chat with our speakers? I've allowed Shiraz to speak already.
Or we can share the JD slides on the chat. Oh, okay.
So just now Shiraz asked a few questions on the chatbot and I didn't answer them because the work that I'm doing is more for the analytics engine for the chatbot. It's not on the chatbot itself. And I realized that a couple of questions that you had was more for the chatbot, like whether it's going to open source and things like that. So yeah, so apologies if I'm not able to address those questions.
Yeah, I think to answer Shira's question in terms of the job role, so maybe I'll do a quick self-introduction. My name is Zhuang and I'm part of the talent acquisition team. So if anyone's interested to find out a little bit more about the openings that we have, I think we have pasted some of the job links in the chat. And if you'd like to find out even more of some of the roles that's maybe outside of the DSAID, please feel free to visit careers at Gov as well, where you have an opportunity to find out more about the different openings that we have under GovTech. And if anyone is interested to maybe have a chat to find out a bit more about how it is like working at GovTech, feel free to reach out to me via LinkedIn, and I'll be happy to maybe answer any questions you may have.
There's a question in the chat on internship opportunities, Zhang Xian.
Yes, so in terms of internship opportunities, we do have as well. Usually it would be similar to the university cycle. So you can actually follow us on LinkedIn, where when the applications are open for internship, it would be shared there as well. So generally speaking, I would say that GovTech here, we do have opportunities across the board, even if for internship or if you're a fresh graduate to mid to senior professionals, we do have job openings that will be suitable for everyone.
Park Chuan, you raise your hands. Can unmute yourself if you'd like to speak.
Hi, can you hear me?
Yes.
Hi, I have a question about internships. So for an internship at DSAID, what kind of skill sets are you looking for in an undergraduate student, particularly in the earlier years of university?
Sure, maybe I can just give a quick overview in terms of some of the requirements we're looking for then. So I would say it kind of depends on the kind of positions you apply to, that's one. And I would say if you have relevant coursework, meaning you have gone through maybe the computer science related degree, as well as some of the maybe relevant internship experience, they'll be very helpful. And I would say usually the team will be evaluating applications to take a look at the kind of experience, exposure you have in school, internship, or even some of the work that you do outside, and they will be able to evaluate and see if you're a good fit.
Yeah, Zhang, if I may just jump in as well. So I think with regards to the interns, even my team of the small team, Park Chuan, we actually develop our own codality-like test like Hackernoon, because we realized that not everybody who is interested and also in fact suitable for it necessarily are from like the School of Computing, right? We have people from chemical engineering. I think even people can come in from the liberal arts background. And so really we just want to test your ability to think computationally. And yeah, I think they are definitely test requirements. So it's not just like paper qualifications, I guess. Yeah.
Thank you.
A Coral also raised her hand. Yeah, so I've allowed her to speak.
Hi. Sorry for the echo just now. I would like to find out what are the job opportunities for experienced staff.
Yeah, sure. So maybe I can give a quick introduction as well in terms of some of the openings that we have. So if you're looking into specifically into the DSAID team. So DSAID actually consists of 5 different sub-teams. So we have capability development, we have video analytics, quantitative strategy, we have data engineering, as well as AI platforms. So within each of the teams, they'll usually be looking out for different talent. So for example, it can be data engineers, data scientists, we have software engineers, DevOps engineers, product managers, program managers, etc. So I think in the chat, we have posted some of the live roles and openings that we have. So you can take a look at maybe the JD there and see if there's anything suitable for you. If you can make an application, then I will be able to review the profiles received and reach out to you if we find your background suitable.
Yunshu, you want to speak?
Yeah, hello. I just have a quick question. So is the position and opportunity open for a foreigner or only for Singapore citizen and PR?
Thanks, Yunshu. I think that's a good question. And I think generally speaking, we do open some positions to hire foreigners in niche skill set. We do want to also note that because as part of public agency, some of the information and data that we are actually dealing with can be quite sensitive. So there are some specific positions that we would only be able to consider Singaporeans or PRs due to the nature of the work when it comes to the sensitivity of the data.
Hi, I just wanted to find out, like, what's the progression like for scholars compared to non-scholars in GovTech?
Okay, that's a good question. When it comes to progression of scholars versus non-scholars, I would say that generally speaking, we treat all of employees equally. Just that for some scholars, they do have a structured program whereby they'll be going through certain rotations for them to get more exposure. But other than that, I would say that a lot of things really depends on each individual's performance. And I think we are quite a performance-driven organization whereby we look into the kind of value and output that you can contribute to the team and make a so-called decision when it comes to career progression. And I think a popular question as well, if I might address, a lot of people may be interested to find out as well. Let's say, for example, you are a software engineer, data scientist, what kind of career progression you can have? Generally speaking, I would say there are 2 different tracks. The first track would be more on the depth side of things, whereby you can specialize and be a little bit more focused on a particular tech stack or technology. The other track would usually then be more on the management track, whereby you would be interested to maybe go into a little bit more on people management. So that is a common question that a lot of people is interested to know as well. And I just thought that I'll use this opportunity to share.
Actually, Zhuang Jian, sorry, can I just clarify, the technology associate program, was that what you were talking about for the rotations?
So I think
because that's not limited just to scholars, right? I mean,
yes.
like people on my team, like literally they have no scholarship. I think they are pretty awesome. Yeah, and I mean they are on that program as well.
Yeah, I think I was assuming that Jing was asking a bit more on the PSLP scholars, whereby we have some president scholars who are rotating among the different public agencies.
Oh, okay. Great.
Ming Luan, you want to speak? Ming Luan, do you have a question that you'd like to ask?
Hi, Neil here. I just wanted to find out more about the specializations that you were talking about. So, like, could you just maybe elaborate on, what are these deeper tracks that you're trying to grow and find talent in GovTech on the data science side? Thank you.
Sorry, Neil, I don't think I got your question. Do you mind elaborating a little bit more?
Oh, because just now you were talking about how there's one track where you are focusing on the growing managers, and the other side is on the depth side, right? So I was just wondering, like, what are some of these specializations on the depth side in data science that you're looking at?
Right, I see. Yeah, so that's a good question, Neil. When I mentioned that part, I was actually just mentioning, or rather referring to a more generic kind of career progression, because when I speak with candidates, a lot of them would be interested in asking questions such as, when they were to join, what kind of career progression they can look forward to. So usually I would tell candidates that the two tracks, one would be on the focusing a bit more on the depth of the technical side. So for example, it could be specializing in just one particular tech stack, right? For example, some software engineers, they may be interested to dive very deep into maybe Golang or some of the front end related technology. And if that's the case, what they can look forward to then is that they can really drill deep into the technical end, and they will be the go-to expert in the future. Whenever some other project teams, they have any questions related to this particular technology, they can then reach out to this person. The other stack I was referring to is more on the so-called people manager kind of career path. And I think for this route is usually for people who perhaps after a while feels that they maybe don't want to do hands-on that often, and go into a bit of the people management track, whereby they'll be focusing more on the strategic side of things, managing stakeholders, convincing stakeholders, and the time they will be spending on hands-on work would then be lesser, and they will spend more time on stakeholder management, people managing, performance appraisal, etc.
Okay.
Yeah, I hope they answer your questions.
Yeah, that's very clear. Thank you.
Okay, we actually have a few more questions. We have Sean, we have Karen Wong, we have Matthew in the chat, as well as Kun Kiet. I think Kun Kiet's question is also directed at Jing Song regarding someone from chemical engineering doing data science work. Maybe Jing Song, you can elaborate a bit on that.
Yeah, we have an intern right now doing it, but he was put through the equivalent of like codality test. So that's not an issue. I mean, it's the same kind of things, right? Like I say that one very interesting problem we are solving is actually a graph problem, like essentially nodes and edges. And I was just telling him last week when he joined that, you look at chemical compounds, actually it's quite the same, right? You look at bonds and the different elements and how they bond together. So modeling is, it's just about, so generally I think as long as somebody is able to think, model through a problem, work through it, convert the business logic into something that's technical and come out with a solution for it, that's probably what we are looking for. Yeah, or at least what I value. I mean, different teams have different ways of valuing things.
Thanks, Jing Song. Yeah, maybe Karen, do you want to verbalize your questions? Because I saw that you raised your hands and you also had a question in the chat.
Can you all hear me?
Yes.
Yeah, so my question is basically whether it's a good choice to specialize in NLP and even CV in Singapore. And so whether there are also like job opportunities for people who specializes in these two fields.
Okay, maybe I'll try to take that question. So, computer vision, I'm not so sure, but it has the same roots as NLP. Okay, maybe not same roots, but it uses similar techniques as NLP, and text and images are all around us. So like all the feedback data that we are getting, all the emails that we are getting, it's all mainly text data, and people also attach images, and recently people have been posting on social media using images and videos. So I would think that these use cases will be around all the while, unless there's something else that comes up like VR or something else. But for the next few years, I would think that text and image recognition and computer vision kind of use cases will still be around. And I think that there are many opportunities to work on these areas, and there'll be a lot of opportunities. Yeah.
Okay, thank you.
Thanks for all your questions. I think we have time for maybe another 2 to 3 questions. Perhaps our speakers here can answer Matthew's question first before I check who else wants to ask questions. So Matthew is actually asking what is the future plan and direction of GovTech and DSAID, and if the speakers can share maybe some interesting things that are upcoming.
Oh man, I'm looking to the bosses in DSAID. Watson, what about you? They are okay. I'm just so sometimes I work with a nose up against the screen, right? You just have your Visual Code Studio and all your code review, and you don't gaze ahead. But I think that there are some interesting things. So the management, the score can talk about. But there are lots of very interesting data sets that we are looking at, and it's not just about interesting, but how you convert it to public value. So I think if you look at it, government's actually collecting a lot. You can just imagine sensor-like data you have to stream, not just batch processing. It's not just like, I don't know. So it's about big data, really like streaming data, and you have kind of optimization and stuff and whatnot. I mean, we have worked on all kinds of interesting projects involving that. I can just imagine that the opportunities will increase. And we have worked on projects involving our transportation system. And we have worked on projects involving our energy grid, and I think even in Singapore, for Singapore's future, these kind of data-related questions that agencies are asking, GovTech needs to be around to help them. So I can't give a strategic plan. The bosses can give.
Yeah, no worries. Okay, I think we have time for just one more question. So perhaps for those of you who we didn't get to answer your questions, you could also join our Telegram chat because Jing and Watson will still be online to answer any questions. So maybe I can select someone who has a hand up. I know, Sean, you have had your hand up for quite a while. Okay, wait, I don't see you anymore. Okay, so between Ming Lun, Yan Yuan, and Shiraz, maybe let's pick Yan Yuan since you have a question up in the chat already.
Okay, hello, I'm Yan Yuan. So I would like to actually ask how often do GovTech collaborate with other uprising, rising tech organizations like Shopee to ensure that the technology that they are using are relevant, particularly for the data science and artificial intelligence department? Thank you.
My answer, if I may just be frank, Watson can chime in over there. My answer is not enough. I think we should do a lot more. So I have this whole idea. I mean, like GovTech as a whole, I think they are pretty good, like software engineers, data scientists around. But I think as mentioned about the BERT model, I really think we can do a lot more to contribute to the open source community. And that's just me per se. So I mean, if you talk about the Singapore tech scene, I think it will grow, it will increase. And our responsibility, but also I think for vested interest, we really should be more plugged into it. So that's my answer, not enough. Yeah, but I don't know, Watson, what do you think?
I also think that we currently are not doing that much. And I think partly it's also because all these private organizations, they have their own business use cases, which might not be so aligned with what we do in the public service. But there are some parts which are aligned, like building of word models and things like that, what Jing Song said, or English models to understand local context. Yeah, so those things we have, I think they have not we, they have, some of them have contributed and have put on the open source repositories, like on the Hugging-based model hubs. But now at the working level, to really collaborate and work with them to address use cases, I'm not sure how that will turn out also. Yeah, because we solve different use cases. Ours is mainly non-profit and quite specific public agencies and citizen products. So whereas theirs is more for profit and they do things like advertising and things like that. Yeah, but I think if there's a chance and they are willing, then the senior management will link us up and can explore common problems together.
I think there was a question about, sorry, I may have missed it. There was a question earlier about something about the trajectory of DSAID or something, right? So I'll just say that I think the growth when it comes to data science and AI has been very significant in the past a few years. And I think DSAID, for example, has almost doubled in terms of our numbers just in the 2 years alone. And moving ahead, there's so much incredible work that we can be doing across all the various, I mean, there's more than 14 ministries, right? And over 50 stat boards, whether it's in terms of policy decision making, service delivery for citizens, or the efficiency of operations. And I think, as Jing Song has mentioned, it covers from healthcare to finance to logistics to transportation. We had in place this national AI strategy, right, of which the government is also going to play a significant part to support. And one key thing that is definitely significant is that even with the data science projects, to productionize it, okay, whether it's in terms of building sector products, okay, when I say productionize it, it means together with the whole entire data infrastructure, or whether it's in terms of putting in place central platforms that the entire whole of government can use. Okay, so just to give a sense, is fantastic and growing. There was a question asked, I think, also about Shopee. Okay, we just had our Data Science Connect, the 19th edition, just last Friday. Okay, and Shopee came to share as well. Okay, so I think I totally agree with Jing Song. There's definitely a lot more we can do to collaborate. But I think it's just like opportunities like today, where community of like-minded data scientists and good people. And then last Friday, Joseph is my team lead working on the Data Science Connect. And it was wonderful and refreshing to also hear from Shopee what they are doing, okay, at scale with the data that they are processing. I think they are looking at it in terms of petabyte scale. So definitely a lot more that we can learn, but it's already something that we've been doing. We have this central whole of government platform called Transcribe, speech to text. And it's not just us using our own data science developed models, but we partner and use Google recognition. We I2R and AISG labs as well. So just to give a sense, I think that's a wonderful way to end the session. I think that, I mean, I thought it would also be useful to just thank the speakers and whoever is still left. I mean, there's still like 72 of us here, right, at 9 p.m. And all of y'all that have stayed back for the networking session. Thanks for your patience, and to the organizers, to Ku and Ivan, DSSG for supporting as well. That's all I have. Over back to, yes, our organizers. Thanks.
Thank you, Jason, and thank you so much for staying along with all of us and our attendees. And thanks so much also, Ivan, for moderating this really great session. I think we've gotten a lot of questions, and hopefully we answered some of your questions. But like what we said, we will also be taking questions in the StackX Telegram for our speakers. So please join us there if you want to ask any more questions. So once again, thank you so much, everyone, for joining us tonight. And we hope you have a good evening. Thanks, everyone.
Good night. Thank you.
Thank you.